Good morning, students. Today we will have the detailed description about the Pentium architecture. In this presentation, we will learn the Pentium architecture, its different functional units or blocks, and internal functioning of a Pentium architecture. This is a diagram of Pentium architectural design. Which components you are observing here is, see, there is a bus unit, there is a paging unit, there is a separate 8 kilobyte code cache, 8 kilobyte data cache, there is a branch target buffer, uh, code cache followed by a prefetch buffer, and prefetch buffer followed by a instruction decoder. There is a control ROM, and below control ROM there are two pipelines, U pipeline and V pipeline. There are two ALUs, and then there is a separate floating point unit. And floating point unit is also having its own pipeline. It can perform add, divide and multiply instruction. There is a 32-bit address bus, and this address bus is a bidirectional, and 64-bit external data bus. This is all about its architectural functional units. Now we will see the role of every functional units. This is a enlisting of functional unit of bus unit, Pentium architecture, that is a bus unit, paging unit, control ROM, execution unit with two pipelines, U pipeline and V pipeline, instruction cache, data cache, prefetch buffer, instruction decoder, then branch target buffer, dual processing logic, floating point unit, advanced programmable interrupt controller. Now we will see the functioning of every block in the Pentium architecture. What is the role of a bus unit is? Pentium communicate with outside world via a 32-bit address bus and 64-bit data bus. The bus unit is capable of performing the burst cycle, read-write cycle of 32 bytes with the help of this data bus with the memory and through bus cycle pipelining. There are two bus cycles in progress simultaneously. Pentium allows parallelism, that is, it performs two cycles are executed per clock cycles, and that is why its speed is more than other previous processors of Intel family. It is having a paging unit. The page unit offers optional extension of approximately 2 to 4 MB of page sizes. Then control ROM. The control ROM controls the 5-stage integer pipelines U and V pipeline, and as well as it can control 8-stage floating point pipeline also. In the architecture of Pentium processor, the integer pipeline are used for all the instructions which are not involved in any floating point operations. Therefore, the Pentium can transmit two integer instructions in the same clock cycle, and performance of the processor is improved. Due to availability of two pipelines and control ROM controlled by this both the pipelines of integer pipeline as well as floating point pipeline, Pentium is called as a superscalar architecture. Now how U pipeline and V pipelining are functioning. Execution unit. The execution unit within the Pentium microprocessor contains two integer pipelines. Their names are U pipeline and V pipeline. Each has its own separate ALU. There are 5 stages of these pipelines, and these 5 stages we are naming them as prefetch, decode 1, decode 2, execute and write back. The U pipeline is responsible for executing all the integer as well as floating point instruction, while P pipeline can execute simple integer and some floating point instructions. The 5-stage pipeline, now we will see how it is. The first stage is a prefetch. In prefetch, the instruction is prefetched from the code cache into the prefetch buffer. In the second stage of a pipeline, that is decode 1, in a D1, the word is decoded. What is the meaning? Whether it is an arithmetic instruction, logical instruction, because according to that instructions are given to ALU. In the second stage, in decode 2, the controlled word, for whatever controlled word is there, for that operands are generated and its address is generated in the D2. The accessed operands are given into the ALU for execute stage and it is executed. After that, again cache memory is also accessed here, because if operands are present in cache memory. And in the last stage of a pipeline, that is WB, that is write back the result. Your registers or memory locations are updated, means a result is returned to the particular register or the memory locations. Now we will see the functioning of an instruction cache. There are two separate cache are provided. One is an instruction cache and another is a data cache. Both length is 8 KB. In order to load the instructions into the execution unit, code cache, branch target buffer and prefetch buffer operate in together. They are working with hand in hand with together. The code cache or the external memory holds the instruction from where these are fetched. Whenever instruction is executing, and first it is searched into the internal cache memory. If it is not available there, it is called as a cache miss, and that instruction is brought from the external memory and one copy of that one is written into the instruction cache, while the branch target buffer holds the address of the respective branch and the TLB. TLB stands from translation look aside buffer, who will convert the linear address into the physical address that is used for the instruction cache. 8 KB instruction cache is used to provide the quick access to the frequently used instructions. When an instruction is not found in this instruction cache, it is read from the external data bus and a copy is placed into the instruction cache for future need or future use. Data cache, a separate 8 KB data cache stores a copy of the most frequently accessed memory data so that it will be easily available for execution. Since memory accesses are significantly longer, as speed of the external memory is less than the microprocessor, if you are trying to access it from external memory, so many times microprocessor will enter into the waiting state due to unavailability of the operands. Then more clock periods are needed to fetch that data from the external memory. The data and code caches may both will be enabled and disabled with the help of either hardware or software. Both are also using the translation look aside buffer, which converts the linear address into physical address when virtual memory is employed and Pentium is working in protected mode. Prefetch buffer. The branch target buffer and prefetch buffer works together with the instruction cache to fetch the instruction as fast as possible so that microprocessor should not enter into the idle state. The prefetch buffer maintains a copy of the next 32 bytes of the prefetch instruction. In advance, they are prefetched from the code cache into its buffers. Prefetch buffer is having two prefetch buffer with length 32 bytes. Due to the 256-bit wide data output of the instruction cache, it can fetch prefetch buffers having size of 32 byte that combinedly operate with branch target buffer, that is BTB. Both the buffers operate independently. The first buffer fetches the instruction and fills the instruction into its 32 byte length prefetch buffer sequentially until any branch instruction is coming. If any branch instruction has occurred, BTB will check the branch target address, and from that branch target address, next sequence of instructions will be loaded into the another buffer. And likewise, these two buffers from the prefetch buffer work independently. Instruction decoder. It is a part of a prefetch buffer only and it decodes the instruction kept in the instruction queue. that is in the D1 of pipeline stage. BTB, that is branch target buffer. The Pentium uses a technique called as a branch prediction to maintain a steady flow of instructions into the pipeline. To support the branch prediction, the branch target buffer maintains a copy of an instruction in a different part of the program that is located at an address called the branch target. Wherever branch has to take place, that address is called as a target address or branch target. The BTB is used to store the target address and statistical information, that is a history bits about the branch operation. Hence the branch prediction is able to predict the branches and cause the Pentium to use the most likely target as address for instruction fetching. Due to that, flushing of the pipeline is avoided. Next functional unit is a dual processing logic. As your Pentium is having two prefetch buffers, inside the prefetch buffer it is having two ALUs along with two pipelines, U pipeline and V pipeline. Also it is having two separate 8 kilobyte data cache as well as code cache, and whatever that cache memory is, its design type is two-way associative set cache. Each cache is having 128 sets and every set is having two lines which is having length of 32 bytes. The floating point unit, earlier microprocessors from Intel family, that is 8086 or 386, they have to be connected with a math coprocessor for functioning of special mathematical functions. But such a need is not there in Pentium. Pentium is having on-chip floating point unit. The floating point unit of the Pentium maintains set of floating point register whose length is 80 bits, that is from ST0 to ST8, which are very high speed performing math operations. This unit has been completely redesigned from one used inside the 80486, and that is also pipeline. The floating point unit uses hardware from U pipeline and V pipeline to perform the initial work during the floating point instruction, that is fetching of 64-bit operand, and for first four stages, that is prefetch, decode 1, decode 2 and execute, and then uses its own pipeline. That is why floating point unit is a 8-stage pipeline in Pentium and to complete the mathematical operations. Since both the integer pipelines are used, only one floating point instructions can be executed at a time. Last functional unit, that is advanced programmable interrupt controller, that is APIC. uh, in previous Intel family, we have to connect a separate chip, that is 8259A, called as a interrupt controller to handle the multiple interrupts. But that is not needed in Pentium because Pentium is a on-chip advanced programmable interrupt controller that manages the interrupt uh, done as per 8259A compatibility. This is all about the different functional units of the Pentium architectures. We have seen that their internal functioning and how complex the Pentium architecture is. Thank you for listening and have a nice day.